Here we are on section 5.2. We are going to start off talking about the median of a triangle. So let's take a triangle right here and let's talk about what the median is. Well, if you've ever gone down the road, a lot of roads, you'll see a thing called the median. Let's take a look at what a median of the road is. All right, here's a picture of a median. Okay, you've probably seen this before. You may not have seen this road because I picked this off the internet and it looks like this is in kilometers per hour, 100. So they don't go 100 miles per hour. This is 100 kilometers an hour, which is close to around 60 miles per hour. Plus, look at where they're driving. Man, they're driving on the wrong side of the road. Well, to them, it might be the right side of the road. But anyway, just grabbed it off the internet. What's this thing in the middle here, splitting the two lanes? Okay, we call this thing a median. M-E-D. Let me write it down. Okay, it's a median. Right, and we've talked about median probably, well, you probably talked about it in other math classes when you did mean, median, and mode. And median was the number that was in the middle. So think of median as the middle. So with that in mind, let's go back to our triangle and let's talk about what the median is. What the median is a line segment from a vertex, where do you think? Yep, to the middle, to the midpoint. All right, so I'm going to draw a little point right there. That would be the midpoint. That would be a median. So if I go from, let's change colors. If I go from a vertex to the median right there, or to the midpoint, I should say, that would be the median. So if that is the midpoint, so if this segment and this segment are equal to each other, this thing right there is called the median because it goes from a vertex to the midpoint of the opposite side. And I could draw three medians here. I could go from this vertex to the midpoint of this side, and I could go from the last vertex to the midpoint of this side. And you're going to see something that's true about it. Let's skip to our other program. Let's go to our other program that we used on the last lesson and get a little bit more specific because I think we can get a little more detailed with the other program. And you're going to see what happens with the three medians. That's kind of interesting, I think. So let's see what happens. By the way, I didn't tell you the name of this program. It's called GeoGebra. I guess it's geometry and algebra, kind of a combination thing. GeoGebra. You can actually download this for free. Go to, I think it's .com. I'm not sure. I have to look it up. But anyway, just do a Google search for GeoGebra, download, and it's perfectly fine to download it for free. There's nothing illegal about it. You can get this and you can practice and do some of the same stuff that I am doing with GeoGebra. It's kind of cool. So let's do a triangle. I've got the triangle thing here. So I've got this. Let's just make an ordinary triangle. And what am I going to do? I'm going to draw the median. So I want to go from one point to the midpoint of the opposite side. So what I need to do are find the midpoints of all three sides. I have a little tool here. See, it says midpoint or center. I hit that. And all I have to do is hit one of these sides and it gives me the midpoint. Just tap on this side, gives me the midpoint, tap on this side, and it gives me the midpoint. So what I'm going to do now is, see this thing right here, it says segment between 2 points. Right? If I click on that, you can do a bunch of other things, but I'm just going to go segment between 2 points, and there are my 2 points already. So I just click on point A, and I click on that point right there. They called it point D. They just automatically named them. That right there is my median. So I've gone from the vertex to the midpoint of the opposite side. I'm going to do that for all three this time. So I'm going to go from this point to the midpoint. Oops, tap it right there. And then I'm going to go from this vertex to the midpoint right there. And look what they are. They are concurrent lines. That's what these two sections, yeah, I've been talking about it, are concurrent lines, which means they all intersect at the same point, which again, I think is pretty cool. You may not think it's so exciting, but I think it's pretty cool that they actually do intersect at the same point. But there's something way more cooler about that with this thing right here. And I'm going to show you. Now that point's pretty important. So what I'm going to do is I'm going to name that point. See if I remember how to do that. I'm going to do intersect. See where it says intersect two objects. So I'm going to click on that one, click on that one. That's where they intersect right there. And I can rename it. So I right click on there, I hit rename, and here is the word. It's called the Centroid. It's kind of a cool sound and name. Let me get rid of that. All right, it's called the centroid. So that point of intersection, that point of concurrency with these three medians is called the centroid. And you say, okay, well, that's nice enough, but what is true about the centroid? Well, let's play around with this a little bit. Look, I can move this thing around. I can make it, look, that's an obtuse triangle. Where's the centroid? It's still inside the triangle. Is there any way to get that centroid outside the triangle? Nope. Look, I can move this all around like crazy. That centroid is always going to be inside of the triangle. All right, so that's something that's kind of important. But there's something else that's really cool about this that I don't know if I would have thought about on my own. I want to find what's true about this centroid. Remember, with circumcenter and incenter, we found some things that were specifically true about the distance that it was away from either the vertex or the distance to the side. But this time it's a little bit different. It does have something unique about it. And here it is. I'll just tell you right now. And then we'll show you with this program that it actually works pretty nice. Well, look, this centroid right here is actually, how should I say it? It's 2/3 of the distance from the vertex to the midpoint of the opposite side. It's 2/3 of that distance, which means this. From the centroid to this vertex, it's going to be twice as big as from the centroid to the median. And that's kind of interesting. Let me name these points, make it a little easier. I started naming them, but I thought maybe you'd like to see how I name these. So I just right click on here and I hit show label and it names that point. So I don't give it a name, it already names it. And watch, if I want that outside, I just take it and drag it right here, which is pretty cool. So I've named these points right here. From the centroid, we'll just call this centroid. We won't actually give it a letter. We'll just call it centroid. So from C to the centroid is twice as big as it is from the centroid to point F, which is the midpoint. Remember, it's the median, so that's the midpoint. So from the vertex to the centroid is twice as big as from the centroid to the midpoint. So for instance, if I said the centroid from this, C, I guess I should have called it a letter. We'll call it Z, all right? So from C to Z, let's say that was 10. And then I asked you what FZ was equal to. Well, remember, this is twice as big as this. So if this was 10, then what's this going to be? It's going to be 5. All right, and you can do that with x's too. They might say this is, 3x minus 2. Well, that's going to be twice as big as this, whatever they call that thing right there. I might call it 2x or something. So you say that this right here is 2 times as big as this. Or you could go the other way. You could say that this is half of this. So if this is 10, this is 5. Or what if this was 3? What if from E to the centroid was 3? What is it from the centroid to B? Well, that would be 6. All right, pretty simple. That's half of this, or this is twice as big as this. It's pretty good. Let me just show you, and let's see. It's pretty early. I think we don't have a whole lot more to do. So let me just show you how I do this. What I'm going to do is, see where it says segment between 2 points? What I'm going to do is this. I'm going to draw a segment from, see how it makes a segment, and I'm going to touch that point right there. Now it's hard to see, but it actually made a segment from here to here. And I'm going to do the same thing. Now watch, I went from the centroid to the vertex. So I'm going to go to centroid to this vertex and centroid to this vertex right there. And if you looked at it, that's actually, if I wanted to, we'll just do it like this. Watch. That's G. Let me, oh, I'm sorry, I got to click off of here. Watch, that's G, H, and I. So if I hit the Control key, I can actually select all 3. And what's cool about this is, watch, I can go to Object Properties. I can change the color of it. Let's just make it green. And we can actually change how thick the line is too if we wanted to. All right, let's make it kind of thick, like 5. All right, so there I go. So all these are the longest, right? From the vertex to the centroid is the longest side. So this green one is twice as big as this one right here. And let's color those in. Or actually, we got to do the points. So I got to go back to this. Watch, let's go from centroid to the midpoint this time. Centroid, and see what it did? It called it line J. And then I went from the centroid to point E, and let's go from the centroid to point D. And I'm going to come over here. I hit escape to go to this if you want to use a keyboard shortcut. And let's make this a different color. Hit Control to get all three of them. I right click on there. I go to Object Properties. If you want to try this yourself, we'll make it a little thicker. We'll go to 5 point again. And let's change this color. Let's go to red this time. All right, there we go. So this is kind of interesting because I've made all the short ones red and all the longer ones green. What I want to do is I want to see a relationship between these. Now I think I can see that's the whole thing. Let me do that. What I'm doing is I'm hiding these. When you just click on it, it becomes white. It hides it. Remember the black line was underneath of it? Now I just have the short lines. What I want to do now is click on it. So that's J. Now it doesn't say J, but if I click on it, I think I hit Show Object. Nope, that's not it. Let's try this again. Sorry that you're here for my experimentation. Let's click on this and Show Label. There we go. See, there's the J right there. See, it's J here and it's J here. Let's click on, let's see, which one's that one? Yeah, that one's I. So I'm going to click on, I'm going to hit Show Label. We'll just do these two right here. I know it's kind of small, but that's J and that's I. What I want to do, I want to make them a nice whole number so it makes it easy. If you look at it, look at J and I. 3.38 is going to be half of 6.67. All right, remember this is going to be half of this, but I'm just going to make it until there. Oops, almost. There we go. I just made it nice whole number so it could be easy to see. Now watch. If I is 6, that means from C to the centroid, that's I, that's 6. What's this going to be? It's going to be half of 6, and it's 3, and it tells you right there exactly what it is, which is kind of cool. All right, I think that's neat. I could change, watch, let's change I to 4. There we go. Just change it around. So I is 4, and what's J? It's 2. Again, it's half of this thing right here, right? I could have moved all these around and done the same exact thing, but you can compare them and see what's going on. So that's what I want you to see basically, is that the longer segment goes from the vertex to the centroid is twice as big as the shorter segment in that whole median, okay? I'm not comparing this green one to this green one. Look, all the green ones are not necessarily the same. If I went like this one's a lot longer than this one right here and this one right here. So the green ones are not all the same, but the green one in this median is twice as big as the red one in that same median. I hope that makes sense. All right, let's do maybe an example that you're going to see in the book, and then we'll go from there. Okay, here's a quick little example. I saw how they did it in the book. Man, they made it way confusing in the book, okay? I think I'm going to show you a lot easier way to do this. First of all, here's my triangle. Here's the whole situation. It says P is the centroid. So if P is the centroid right there, you know what must be true about it. You know that you must have found the median, okay, of all three sides, which means what? From J to S must be a midpoint, R must be a midpoint, and T must be a midpoint. So that's important if that's the centroid. It doesn't mean that we've bisected these angles, okay? Look at this angle right here. That doesn't look bisected. We did not bisect the angles. This is the median. It hits the midpoint of the opposite side. So anyway, P is the midpoint. And they tell you that PT is equal to 2. So what I'm going to do is I'm going to put a 2 right there. And it says find KP. KP is from here to here. So that's what we're trying to find. In fact, let me just draw it in here and just do it in blue. All right, that's didn't help. But anyway, that's what KP is. And we want to find the length of it. We want to find out how long that is. Well, this is a lot easier than what they do in the book. Remember, this is the shorter side and this is the longer side. How do you know which one's which? Because sometimes, if it's not really drawn to scale, it's kind of hard sometimes to tell which one's the shorter, which one's the longer. Even though one is twice as big as the other one, sometimes the way they draw it, it just doesn't look that good. So anyway, how do you know which one the longer one is? The longer one is from the vertex to the centroid. That's always the one that's twice as big as the other one. Okay, the one from the centroid to the midpoint, that's always the shorter one. Okay, so from the angle, from the vertex to the centroid is always the longer one. So what do we say? We say this is 2. What was that relationship? Do you remember that? This is half of this, or KP, the longer one, is twice as big as the shorter one. And that's pretty simple. So if KP is twice as big as this, what's 2 times 2? Well, it's 4. Pretty simple. So KP is 4. They do it a lot crazier way. Now, I could they don't ask you this on this example, but I could ask you this. They might say find, this is going to be really easy since we found KP already, but they might say find KT. So if they say find KT, well, you already knew this was 2. You knew this was 4 because it's twice as much. So how do you find KT? Well, it's the whole entire thing. It's 4 plus 2, not times. Plus, because you're adding those two segments together. So 4 plus 2 is 6, so KT is 6. What if they did this? What if they told you, let's try and get rid of that blue one. Here we go. What if they didn't tell you any of this, but they said that they told you that KT was 6? Now, I'm using numbers we just used, so you can probably figure out, excuse me, you could probably figure out what's what. But how would you do this? All right. If they told you the whole thing, they told you the whole thing was 6. Sometimes the numbers aren't going to be this easy, but on this one it is. If they told you the whole thing, how could you find one or the other? All right. The easiest way to do this, all right, and in the book, I think they do the 2/3 thing, because this is 2/3. KP is 2/3 of the whole thing. You could go 2/3 times 6 if you wanted to. That'd be all right. But I think this is easier. Remember, this is 1/3. So if this is 2/3 of the whole thing and this is 1/3 of the whole thing, I think it's easier taking 1/3 than it is 2/3. It's not much easier. It's a little bit easier, but I just think it's a little bit easier. So watch. How do I find the shorter one? If I know the whole thing is 6, how do I find the shorter one? Well, it's 1/3 of 6, or taking 1/3 of something is the same thing as dividing by 3. So 6 divided by 3 is 2. So that segment right there is 2. How do I find this? I don't have to go 2/3 of 6. I mean, I could, but I don't have to. Once I find the shorter one, the longer one's simple. It's just double the shorter one. I got 2 and 4. So there you go. If they give you the longest one, what do you do? I think the easiest way to do this is to find the shorter one. How do you find the shorter one? You just divide it by 3. So take the whole entire length, divide it by 3, you got the shorter one. Take that shorter one, double it, and you've got the longer one. I mean, that's what you're doing when you're multiplying by 2/3, aren't you? You're dividing by 3 and then doubling it. But for some reason, some people get a little more confused on the 2/3 thing. So I would take the whole thing, divide it by 3, you get 2, and then double that one, and you get the longer one. I think that's pretty basic and pretty simple. All right, we have one more to do. And let's go back to, let's do this. Let's talk about the word first, okay? And I'll just write it down, and it's altitude. All right, think of altitude as a plane. I'm not going to find any picture on the internet just because I want to get to bed. It's kind of late for me right now. All right, so here's my cool plane. All right, don't laugh. Oh, you're probably laughing already. That's okay. I'm an awful drawer. Drawer, is that a word? So anyway, so I've got an artist. So here's an airplane. If they talk about the altitude, right, the pilot gets on there and he gets on his deep pilot voice. Oh, welcome to Hamrick Airlines. We'll be trying. He always does this with his voice. And he'll say, we'll be cruising at an altitude of 20,000 feet. And so what does he mean by the altitude of 20,000 feet? Is the altitude the distance from like here to where they're going? Is it from where they started? No, it's straight down. People say that all the time, straight down. But let's not say straight down. Let's say what? The altitude, if I said 20,000 feet, it would be the perpendicular distance, okay, from the plane to the earth or to the ground. That's the altitude right there. So altitude means perpendicular. What does it mean to be an altitude of a triangle? Well, let's draw a triangle and let's talk about what it means to draw an altitude of a triangle. It means we start at a vertex again, and we go perpendicular to the opposite side. This side over here is the opposite side, so we got to go perpendicular. It wouldn't be here, it wouldn't be here, it would be right there. So that would be an altitude, right? So what we're going to do is we're going to draw 3 altitudes, and we're going to find out that those 3 lines are concurrent and it has a name, and I'm going to go to the other program, the GeoGebra program, and we'll see if there's anything true about that. All right, here we go. Let's draw our triangle again. All right, so we got a nice little triangle right here. And what we're going to do is draw the altitude to all three sides. What do? Go from a vertex perpendicular to the other side. So I've got a little perpendicular tool, and it's actually right there. See, perpendicular line. And it even tells you what to do, how to do this. Perpendicular line. It says select a point and a perpendicular line. So I want to select here, I think. Yeah, oops. Let's try this again. Select a point and let's select a line. Oh, there we go. And it draws a perpendicular line for us. Very nice. It doesn't put the little right angle symbol. It'd be nice if they do that. Maybe there is a way to do it and I don't know how to do it, but that's how you do that. So let's draw another perpendicular. Let's go from this point to this line right here. And we've got another perpendicular, right? It goes from here, perpendicular. That's an altitude. Those are two altitudes. Now, hopefully, if everything goes as, you know, what we've done before, if I draw an altitude from here to here, look at that. They all three intersect, which again is really cool. It's cool that they intersect each other at that point. That's a point of concurrency. Let's we go down here, we say intersect two objects. I click on one line, click on another line, gives me a point. I right click and I'm going to hit rename that point. And here's the crazy name. It's called an orthocenter. Orthocenter. Don't know really where, oops. I don't know really where they got that name from, but that's what they call it. I'm not going to look it up right now. So it's called the orthocenter. Now, with the other three things, the circumcenter, the incenter, and the centroid, there was something unique about that point, right? On the circumcenter, it was equidistant from the vertices. On the incenter, it was equidistant from the three sides. And the centroid, it was 2/3, right, from here to here and all that kind of stuff. Well, the orthocenter, there's really nothing special about it. All right, sorry, orthocenter. Hope I didn't hurt your feelings, but there's nothing special about you at all, okay? Except for the fact that it is that they are concurrent. That those three lines are concurrent, which means they have a point of concurrency. They all intersect in one point. Other than that, there's nothing. They're not equidistant from the sides, not equidistant from the vertices. There's nothing really special about the orthocenter. You could look at it this way if you want to. Watch, if we make a obtuse triangle, the orthocenter is outside. If it's acute, it's inside. If it's right, I don't even think that there's anything special about it if it's right. Maybe, yeah, maybe there is. The orthocenter lies right on the where the right angle would be. So other than that, there's really nothing special about the orthocenter. So that saves us some work, which is kind of nice, but that's what the orthocenter is. How did we find it again? Well, we found the altitude. We went from the vertex perpendicular. Did you see that? It's perpendicular to the opposite side. They don't have the little right angle symbol, but that is perpendicular. So is that, so is that. And they all intersect at that point. So there you go. They have a nice little chart on page 337. Okay, there's a chart on page 337 that talks about all four of these because it can be very, very easy to get confused between the four. So it's very important that I think that you go through and you look at that chart and you remember, how did you get the circumcenter? How did you get the incenter and the centroid and the orthocenter? And what's unique about those points? On the orthocenter, there's really nothing unique about this point. But with the circumcenter, the incenter, and the centroid, there definitely are. So you want to make sure that you go through that kind of stuff. All right, look at that. I'm done before 25 minutes. So I'll be quiet and I'll let you get ready to do the next lesson. All right, we'll see you next time we have class. Bye.